Hi. So as a part of this lecture, we will look at the basics of a DC motor. What I plan to discuss today is first what a DC motor looks like. Then I would like to go over an intermediate concept called as duty cycle. And after we understand that, then I would like to touch upon how we can control a DC motor. So we've seen DC motors in our lives. This is what a small DC motor looks like. It can be used to control small mechanical applications. We've seen it in toy cars, in robots. It works on the basic principle that if you have a magnetic field, two magnets, and in that if I place a coil and I pass current through it, it experiences a magnetic force, this coil, and this coil can actually start rotating in presence of this magnetic force due to this field and the current. So any typical motor has two terminals. You can see the first terminal. Similarly, there's another terminal. The polarity can be reversed. So depending on how I decide to connect it, my direction of rotation will change. So the direction depends on polarity, and the speed of the motor actually depends on the voltage that I apply at the terminal. So please understand these 2 points, that the direction will depend on how I apply the polarity here. Suppose if I reverse the polarity, then the direction would change, and we will understand how to use that as a part of our application. So after understanding the fundamentals of a DC motor, I want to just spend 5 minutes on a concept called as duty cycle. Now we all know that if I have a particular square wave of a fixed period, such that this would be Tp, or the period of my square wave is equal to Tp, and if I'm able to divide this into two parts, that is T on and T off, that is the amount of time, if this is amplitude versus time, then duty cycle would be the amount of on time that I have, which is equal to T on upon Tp, which is the on time upon the total time period, on time upon total time period. I can also see this as T on upon T off plus T on, because T on plus T off is equal to Tp. This basic concept is called as duty cycle. So if my on time is equal to my off time, then that would effectively mean my duty cycle is 50%. I hope this basic thing about duty cycle is clear. But then the question is, why would duty cycle actually matter to me? Depending on the amount of on time I have, again, please make sure that for me to have a duty cycle, my duty cycle does not mean that my time period is different. It's only that my on time changes. If you see that my on time changes, but my Tp is still the same. I hope this point is clear. Another term that I would like to introduce to you is the process with which I can vary my on time is called as PWM, or pulse width modulation. Is that I am changing the width of my pulse, as you see, I change the width of my pulse, and this is done by a process called as PWM. Now you might be questioning is, how does that really affect my motor? Why am I discussing this, and how do I use this for my motor? So if I have a wave which has a duty cycle of, let's say, 50%, if I say that the on is 5 volts and this is 0 volts, then my average of this wave is equal to 2.5 volts over the time period. This is theoretical. Practically, you would have anything between 2.3 or 2.4 to 2.6. It changes. But my average DC voltage, or my average, would be at 2.5 volts. If my duty cycle was, say, 80%, then my average would be around 4 volts, because 80% of 5 is equal to 4 volts. So how do I average this out? I take my square wave and I give it to something called as an integrator. An integrator is a resistor in parallel with a capacitor. So when my square wave appears here at the input, this capacitor starts to charge. It charges to a point as long as this is high, and once it's low, it slowly discharges. But the average value is what I get at the output. Again, the width of my on time would govern what is my average DC voltage. So how do we apply this to the motor? We know that the motor has a coil. The coil is nothing but an inductor. A parallel RC circuit is equivalent to a series RL circuit, where your L is an inductor and R is a resistor. That said, if I apply my square wave, or I'll be more specific and say a PWM wave, or pulse width modulated wave, to my motor, which is your RL, because the motor has its own resistance and the coil acts as an inductor. So the width of my pulse will thus change my average DC voltage to my motor. And as we all know that the average DC voltage of my motor will then affect the speed of my motor. So just to revise, PWM affects the DC voltage and the DC voltage affects the speed. So if I would like to operate my motor at a particular speed, I have to give it a constant PWM pulse of a particular width if I want to operate it at a constant speed. Please make note again that your pulse time period must be the same. TP cannot change. The only thing that can change is your on time. So once you decide and you fix your TP, you cannot change that. So I hope that this particular lecture on the basics of DC motor and how do we use a DC motor using a PWM wave was clear. Thank you.